Welcome everybody to Integrated Math 3. In today's episode, we're going to be discussing chapter 2.2.4, which is transforming non-functions. And so the first non-function I want to introduce you guys to is this x equals y squared. And so to do this, we're going to go ahead and make a table, except this time, instead of making it an xy table, I'm going to make it a yx table. And the reason why I'm doing that is because it looks like right now the inputs and output roles have been switched. It looks like we're going to be inputting a y and getting an x out of it. And so from here, I'll go ahead and just plug in, -2, -1, 0, 1, and 2. And then we'll see what kind of x values we get. And so if I plug in a -2, if I square it, I'm going to get 4, 1, 0, 1, 4. Now these output and input values should look somewhat familiar. It's almost like a parabola. And so if I was to graph this thing as if it was a parabola, I'm going to graph the coordinates normally, except I got to remember one thing. My coordinate system here is backwards. So my first coordinate is not going to be -2, 4. It's actually going to be 4, -2, because remember, coordinates are still read as x, y. I just switched the table just so that I could see it more conveniently. So I'm going to go to 4, 2, or 4, -2 anyways. I'm going to go to 1, -1, 0, 0, 1, 1, and 4, 2. Right? Again, I'm reading the table backwards here. Sorry about that. The program a little glitched out right there. All right, so now I'm going to go ahead and link these things up, and this right here is what we call a sideways or sleeping parabola. And of course, it's a sideways or sleeping parabola because it literally is sideways. And so what we're going to learn today is we're going to learn how to transform this particular non-function right here. So give me a second, I will be right back. So let's take a look at what happens when I introduce a -1 on the inside. Now, based on our transformations from before, in fact, I'll go and write down our last version of a transformation that kind of looks like this. Now, we did this once before, back when we were studying regular transformations, and what did we find it to do? Well, we found that this would shift the parabola to the right by 1, and it would grow like a normal parabola. We saw that. Now, of course, what happens when I do this instead? Notice the -1. The -1 is attached to the y this time, and it's happening inside the functional area, which means if the transformation is happening before the function, it always occurs opposite our intuition. But again, because it's attached to the y, it won't be doing a shift horizontally, because any horizontal shifts deal with x. So take a second and think, what do you think that -1 is going to do to our sideways parabola? If you thought it was going to shift everything up by 1, you are correct. And that is because the transformation's happening before the functional part, right? And it's affecting the y, which is opposite our intuition because we're still inside. And so from here, let's go and take a look at a few more transformations. If I was to do y plus 2 squared like that, what would happen is you'd end up with a downshift of 2. If I was to do something like this now, y squared plus 1. Well, remember, now what's happening is the +1's happening after the y squared is happening, after the quote-unquote function is happening. So that's going to occur with our intuition, and because this is outside the y's functional area, it will actually affect the horizontal movement. So it'll look like this. And then likewise, if I was to do an x equals y squared minus 1, and again, what I'm doing is I'm just applying all these rules of transformations, but backwards, right? Because remember, this is a y function now. In fact, to even call it a function is not even correct. This is a non-function, but if we look at it in terms of an analogous functional idea, the rules behave exactly the same way. So let's go ahead and do a couple of simultaneous transformations. So let's go ahead and do x equals, let's say, y minus 3 squared plus 1. Well, let's take a look at what this is going to do. Well, the minus 3 that happens on the inside is going to shift this sideways parabola up by 3, and then this plus 1 is going to shift it to the right by 1, giving me a coordinate of 1, 3 for the vertex or the locator point, and then it's going to grow like that. Remember, the coordinate system is still the same. It's still x, y, so that's why the vertex here is not 3, 1, and that's a mistake you're going to make, so please make sure you're mindful of that. And then we'll go and do one more, where it's going to be x equals, say, negative y plus 2 squared plus 4. Okay, so let's see what this thing is going to do. So from here, again, the plus 2, what's that going to do? It's going to shift me down by 2. Plus 4 on the outside shifts to the right by 4. So my vertex or locator point is 4, negative 2. And because there's a negative on the outside here, normally our sideways parabolas were opening to the right. This guy will instead be opening to the left. Opening to the left instead. So hopefully that makes sense. I will be right back with the next example. And the last non-function we're going to study today is this. And so I think you've been exposed to this in Integrated 2. This is the equation of a circle. And so if I was to give you an exact version of this, it would be x squared plus y squared equals, say, 25. And if we were to graph this thing, hopefully you would remember from Integrated 2 that the center is at 0, 0. And because the r squared value is 25, that means that the radius is 5, which is why I'm going up, down, left, and right by 5 spaces, and I will go and put those points there. I will label all of the points that I have placed, 0, 5, negative 5, 0, and 0, negative 5. And then as best I can, I create a circle out of it. Of course, we always label accurately, but graph approximately. And so let's talk about transformations that happen with this thing. Now, we've already seen this happen in Integrated 2, right? And so if I did, say, x minus 2 squared plus y plus 1 squared equals, say, 9, the Integrated 2 version of it, you would know that the center is 2, negative 1. Now, another way of looking at that is you could see this as a shift right by 2 and a shift down by 1. So this transformation of the non-function is actually something that is not terribly new. You know, we're going to go to the right by 2, down by 1. And then our radius is 3, so we're going to go up 1, 2, 3, to the right by 1, 2, 3, to the left by 1, 2, 3, and down by 1, 2, 3. And then we circle it up and we label our points. So again, the notion of transforming a non-function is actually something you've been very much exposed to and something that you know. And so from here, if I just go out to the right by 3, I'll add 3 to the x-coordinate, so 5, negative 1. Back 3, that'll be negative 1, negative 1. Up 3 will be 2, 2. And then down 3 will be 2, negative 4. Again, I'm just adding or subtracting 3 depending on the direction that I'm moving. And so I think that will cover it for transformations of non-functions. I find it to be pretty basic, but as always, please feel free to leave any comments or questions in the comments area, and I will see you all in the next episode.